Hello again. Yes, we're getting two in today. Okay. It is 1.6. Okay. You should be doing, this is lesson 1.6, scientific notation. Okay. Sort of did one or two problems from negative exponents with it, so we're going to do more with it now. Okay, here's your bell work. If you want to do that, try it. Push pause and then push play when you're ready, because here are your answers. Okay, push pause and read over those. If you got them right, awesome. If not, it's okay. We'll work on them. Other than that, let's get into today. This is for me, not for you. Today, we are learning to write numbers in standard form, which standard form, you would remember, is just how you write it normally or how you see a number normally. So you don't see a number 300 plus 40 plus 5. No, you see it 345. You say 345. Okay? Also writing numbers from standard form into scientific notation. Okay? And you may know a little bit about it, you may not, might ring a bell. But vocab, okay? It's a little bit of a long one. So, the scientific notation is a system of writing numbers using multiplication and powers of 10. So, from our last lesson, those powers of 10. Okay? A number of the form a times 10 to the n. Okay? There should be an exponent n, not times n. Okay? Where a has to be. Okay? This is very important. That number you're timesing, okay, you'll have a number, usually a decimal, times 10 to some exponent. A lot of the time, all the time, that a needs to be between the numbers 1 and 10, okay? If it's not, then we need to move it over till it is and adjust our exponent accordingly. Okay, pause it if you don't have it down, because we're going to move on. Okay, we just did that. Awesome. Or, hold on, let me go back real quick. Okay, if you look down here at this example, so here's what we're going to be doing. We're going to be taking those standard forms, so like this is how you see 425 million, right? Taking numbers and putting it into this. This is scientific notation. So 4.25 times 10 to the 8th. Okay? And then we're going to be taking these and turning them back into this. Okay? So, going, I'd say, from a number and putting it into standard form is really, really easy, I think. Okay? Oh, hold on. Okay? So, we have 5.34 times 10 to the 4th. Okay, so there's two things you always need to look at when we're dealing with scientific notation and trying to turn it into standard form. That's our decimal, where it's at, and what number our exponent is. Okay, so for instance, 5.34. All you have to do, so here's where the decimal is, check, 4. If it is positive, remember I told you like the number line. Positives are that way, negatives are this way, to the left. Negatives to the left, positive to the right. If it's positive, that's how many times you're going to move that decimal to the right. Okay? So 5.34, we move it once, twice, 3 times, 4 times, and rewrite it. Okay? Wherever there's these little holes, that needs to be a 0 in each. Okay? Then we rewrite it. So 5, 3, 4, 0, 0, 1, 2, 3. There needs to be a comma here. So our answer in standard form is 53,400. Okay? Oh, come on. Unfreeze. There we go. Hey. Okay, there we go. Just move it 4 places to the right. So you try this one on your own, moving that decimal place. So remember, it's 9.62 times 10 to the 5th power. So remember, you need to find where that decimal place is, and then move it that many times the number of the exponent. So if it says 5, for instance, you need to move it over 5 times. Okay, and then rewrite it. So push pause and try that real quick. Push play when you have it done. You should get 962,000. Okay, well what happens if we have a negative number? Well, sort of told you, still the same thing. Okay, so this is 3.27 times 10 to the negative third. Okay, so rewrite your number. Here's where our decimal is. Okay, and it says -3. So we're not going to go to the right that many times. We're going to go to the left that many times because it's negative. So we see that it says 3. So we go 1, 2, 3. Okay, and there's 2 little holes. We need to put zeros. So bring that decimal down. 0, 0, 3, 2, 7. And that is what you should get. Easy peasy. Okay? So you try this one on your own. Okay, it's 2.85 times 10 to the negative 5th exponent. Okay, so remember, since it's negative, we're not going to the right, we're going to the left. Okay? So push pause, push play when you have it done. You should get a lot of zeros. Okay, 0.00000, 4 zeros, 285. Okay? So what happens when we need to write it back into scientific notation? Okay? Well, that's where things can get a tiny bit complicated if you're not careful, but I know you all are very capable. If I can get this to freeze, like Mr. Niemeyer is not capable of getting it to freeze. Okay? So we have 3,725,000. Oh, it's been a long day, guys. 3 million. No, wait, I said it right. Okay? So, what we're going to be doing. Here's where the decimal is. Remember, you need to find where that decimal is. It's always at the end if it's a whole number. Okay? Now, every number that's been in front, so we've had like 3.45 times 10 to the something power. This number always needs to be between what two numbers? 1 and 10. Okay? So, we're going to move this until the number in front of that decimal is between 1 and 10. Then we can stop. Okay? So, 1, 2, 3, 4, 5. Well, if I put it here, that's 37 and 25 hundredths. So that's not between 1 and 10. If we go one more, it's just 3. 3 is between 1 and 10, so we can stop and make the decimal there. So write your new number, 3.725, always times 10. Then you just count how many times. 1, 2, 3, 4, 5, 6. But here comes the part that can be tricky. Is it a positive 6 or is it a negative 6? Okay, well, you went to the left, right? So it should be negative 6. But this is what you're given. Okay, we're putting it in scientific notation. If you were given this number and you know you have to get that, would you move this number to the left or to the right? The right. So it has to be a positive 6 if you're going to move it to the right. That's where it can get tricky. Okay, so just think, if I'm going from here to here, I would move it to the right, so it has to be a positive 6. Okay? Okay, try this one on your own. It has a lot of zeros. Okay? Remember, that that decimal is right at the end of a whole number. It is a whole number, 931,500,000. Okay, write that in scientific notation. Push pause. You should get 9.315 because that is between 1 and 10. Remember, we want to get it between 1 and 10. Okay, so 9.315, and it should be times 10 to the 8th power. Yes, you came to the left, but if you were to take scientific notation and put it back into this number, you'd be going to the right. Okay, so it's a positive 8. Okay, well, what happens when we have a decimal? Okay, it's the same way. We have 0.000316. Well, same thing. Find that decimal, okay, and start moving it till we make a number that is between 1 and 10. Okay, so 1, 2. If I stopped here, that'd be 0.03. That's not even close to 1. Okay, if we go one more, well, that's 0.3. It's not between 1 and 10, but we're getting closer. If we go right here, 3.16, and 3 is between 1 and 10. Okay, so we can stop right there. Rewrite your number, 3.16. Always times 10. Now remember, 1, 2, 3, it's gonna be a 4, but is it a positive or is it a negative 4? Okay, well, you went to the right, but if we started here and you looked at 4, would it be a positive 4 to get this number, or would you have to go to the left to get that decimal and it be negative? You go left, so it has to be a negative 4. Okay? Usually, whole numbers will make positive exponents, and decimals going into scientific notation will make negative exponents. Okay? Well, holy cow. There we go. Hey. Oh, no. What's happening? Don't look. Okay. Try that one on your own. Okay? So write 0.00, so 2 zeros, 44 in scientific notation. Okay? Try it. Push pause and then push play when you think you have it. You should get 4.4, because remember, it has to be between 1 and 10. So 4.4 times 10 to the negative 3rd power, because we came from the left. Okay? Okay. So refer to the table at the right. Order the countries according to the amount of money visitors spend in the United States, from greatest to least. Well, all you have to do, really, I'm not going to spend much time on this, because all you have to do, take their decimal and move them that many places over to the right. Okay, so there's times 10 to the 7th, times 6, or times 10 to the 6th, times 10 to the 6th, and times 10 to the 7th. So you can do that on your own if you want. Okay, pause it and try that, and then put it in order from greatest to least. Remember that, always read directions. If you put it from least to greatest, it'll get counted wrong. So, greatest to least. And you should get, if it'll show up, yep. Okay, so try this one. And again, this one will be very, very easy. Since they all have the same exponent, do we really need to go that many times that way? No, because they're all going to be the same number going that way. So you just have to look at the decimals themselves and place them in order from greatest to least. Okay, so we have 6.7, 6.1, 5.1, 3.8, 7.5. Okay, and what we got for an answer was reverse rainbow. Okay, violet, blue, green, orange, and red. Okay. Oh, we're good with that. that is 1.6 scientific notation. The next two episodes my gosh, today's a long day, guys. Just send me canes. Just kidding. We'll eat it together. So what we will be doing, there will be two more tomorrow. So 1.7, 1.8. I believe that those are adding, subtracting, multiplying, and dividing using scientific notation. So we do a little bit more with that. And then 1.8, let's see. 1.8 is square roots and cube roots. Okay, I promise that'll be easy. Okay, so it's all downhill from here, getting closer to that test. Okay, so have a wonderful Thursday.